This question is from GATE 2016 Mechanical Engineering paper set 2, question number 30. A mass of 2000 kg is currently being lowered at a velocity of 2 meter per second from the drum as shown in the figure. The mass moment of inertia of the drum is 150 kg meter square. On applying the brake, the mass is brought to rest in a distance of 0.5 meter. The energy absorbed by the brake in kilojoule is dash. Let's find out. I'll start by writing the given things. Mass is given to be of 2000 kg. Velocity of the mass is 2 meter per second. Mass moment of inertia is 150 kg meter square. Brake distance, let's denote it by D, is 0.5 meter. And we have to find out the energy absorbed by the brake, which will be nothing but the difference between initial energy and final energy of the brake. So we can write it as delta E, which is nothing but energy absorbed. So as I said, this energy absorbed is nothing but initial energy minus final energy of the brake. Let all the values for initial stage have the subscript 1, that is velocity at initial stage be v1, angular velocity be omega 1 and the distance travelled be h1, and for the final stage let the subscript be 2. So these terms will be v2, omega 2 and h2. Let's write down the energies now. Initial energy can be calculated as the sum of potential energy and kinetic energy. Kinetic energy also has two components because the mass is traveling downwards undergoing a translational motion and the brake drum is rotating. So there is rotational kinetic energy and translational kinetic energy. Rotational kinetic energy can be written as half into I into omega 1 square. This is for the initial value, plus translational kinetic energy can be written as half into mv1 square, and potential energy is mgh1. We can write the final energy as well. It is half I omega 2 square plus half mv2 square plus mgh2. Now as we can see, after the brake is being applied, the mass comes to a rest, and that is why we say this translational velocity final value is 0 meter per second, while the given value is the initial translational velocity, that is 2 meter per second. Similarly, rotational velocity for the drum will also be 0 for the final value, but initially omega 1 has to be found out. Omega 1 will be nothing but the translational velocity v1 by the radius, and radius of the drum can be calculated from the diameter given. Diameter is given to be 2 meter. So radius will be simply 1 meter and this will be equal to v1, which is 2 rad per second. So this value is also 2. Further simplifying this, we have, taking all common terms out, half I omega 1 square minus omega 2 square plus half m v1 square minus v2 square plus mg taken common h1 minus h2. So all other values we have figured out what it should be. But what about h1 minus h2? Distance travelled by the brake is nothing but h1 minus h2. That is the change in height of the mass. This distance is already given to be 0.5 meter. So we can take it from here. Let's substitute all the values and find out the energy absorbed by the brake. Delta E will be equal to, first term, half into 150 into omega 1 is 2 minus 0, which is nothing but 2 square, plus half into mass is 2000 kg into v1 is 2, again 2 square, plus mass is 2000, gravitational acceleration 9.81 into h1 minus h2, distance is 0.5 meter, and we are taking all other values in meter per second here also and kg meter per square here. So we can take this distance as it is in 0.5 meters. This, when calculated in digital calculator, gives the answer as 14,110 joule. To convert this to kilojoule, we divide it by 1000. We get the answer as 14.11 kilojoule. Let's go back and fill in the answer. So the energy absorbed by the brake in kilojoule is 14.11. To learn more about brake systems, you can refer to the NPTEL video Brake System Part 1 from the course Fundamentals of Automotive Systems. This course is by Professor C.S. Shankar Ram. He is from Department of Engineering Design of IIT Madras. I hope this solution will help you clear your doubt. Thank you.